Welcome back, welcome back. It's the same day as the streaming. Subscribe, comment, drop a like if you haven't. We just did our daily streak. Now we can do the CS193P. I'm very excited about this class actually. Let me know what you guys think of the format and how to make it more interactive. We got some suggestions to do a room of binary search every day and then study after that. A little bit time intensive, but I think if we limit the time as possible. I'm currently doing alternative approach. Binary search one day streak plus Scott lecture and course study. I get more either when we do the assignments. But here we go.
Stanford University.
Okay, welcome to Lecture 2 of Stanford CS193P, spring of 2021. So in Lecture 1, we started off on our quest to build a card game here with just a little text, hello world, and we learned how to modify it, change its color, put padding around it, and then how to combine it with another thing, this rounded
It's 1080. Really?
rectangle using a Z-stack. Now we're going to take an even bigger jump, which is we're going to make multiple of these cards. Making multiple cards, we're not going to quite jump all the way to having a whole grid of them here. We're going to start by just making a single row of them. It's actually quite easy. We just need another view combiner. This view combiner is called an H stack. So that's horizontal stack. We're stacking them horizontally.
Actually, one X is really slow.
This Z stack that we built right here, and I'm just going to put 4 of them in here. And all I used was an H stack to combine these Z stacks. This code is kind of gross, though. If you really had to program this way, imagine we have 20 cards. We're going to have 20 of these Z stacks with around. No, I mean, clearly we're not going to do it this way. And why? Because, for example, this still says hello world. We want these to be emoji in here. So we're going to edit each one of these to be something. No, we're not going to do that. Makes no sense. So how are we going to clean this code up dramatically to make it make a lot more sense, both to a reader and to make our code really manageable? What we're going to do is create a dining room chair Lego. Remember I told you that we can create Lego out of other Legos. We kind of did that with a Z-stack here. We created one card Lego, kind of a dining room chair Lego. We kind of did it on the fly. There's no reason we can't create a new struct that behaves like a view, which is a card view, a dining room chair view, if you want to think of it in the Lego terms. We can do that anytime we want. And in fact, we're going to do that all the time because in SwiftUI, we really want our views to be quite small. We want them to have very little code in them. It's better to have more smaller views than fewer larger views. A view with this many lines of code is pretty rare.
Do a for loop maybe.
Because imagine how complicated our card UI is over here. And yet I'm telling you that even this many lines of code is a lot in a view. Okay, lots of small views. That is the design paradigm of SwiftUI. So we're just going to take this little Z stack of the rounded rectangle on the text and make our own new struct that behaves like a view. I'm going to call it CardView. I'm literally just going to go down here and type it in. It's a struct. It's called CardView. It behaves like a view. That means it has to have a var body, which is some view. I'm going to set the value of it by throwing a function right there. It's going to have to return something. It's going to return this Z stack right here. So I'm going to copy and paste that right there. Of course, we don't need the return statement right there. And voila, I've now created my dining room chair.
So that's a modular function kind of thing.
I use that up in here in the same way that I would use any other view, any other Lego. Like
you type it 4 times.
Rectangle. I can just replace all of these by just putting a card view here. Okay? And we know that open parentheses is closed parentheses. That's how we create something. So I put 4 of those in there. Now, if I resume, I get the exact same result as when I had all those Z stacks in there. And look how simple all this code has become. Much more understandable,
it's just modular function,
and much more powerful all at the same time. Okay, what you see right here, this is the heart of doing SwiftUI programming, is defining these dining room chairs and then stacking them together and modifying views as you need them along the way. Let's go ahead and make our things look a little more like cards by getting rid of hello world and putting an emoji there. Pretty much all Mac apps.
Yeah, I agree.
Xcode has got the same thing. Have this emoji and symbols. You can
copy and paste stuff. Yeah.
You can also do Control Command Space to bring that up. We're going
Let me copy and paste stuff. We can literally do a for loop here. Yep. Counts 4. That would make more sense.
I'm going to do the same thing that we did over here and have travel ones. Okay, so our little travel emoji right there. So I'm going to go back
to 32 there.
Start with airplane. So I've just put an airplane in there. And that worked great. Kind of a small little airplane. These are huge cars, small airplane. So I'd like to make this a little larger. Again, at any time, even after I've done this factoring, whatever, I can always click on this text, go over to the inspector. For example, its font can be set. You see, font inherited. I'm going to switch it to large title. I believe that's the largest built-in font that there is. And that made it larger. Now, it's still not quite as large as these ones are over here. They're still kind of small, and we're going to learn next week a little bit how to make the font even larger and also to make the fonts kind of more fit the size of the card they're on. So this is a smaller font, and this flags, for example, is a much larger font. So we'll learn all about that next week, but for now we're going to use this built-in font that we have here, large title. It makes it look a little bit better. Now, we're pretty proud of ourselves having gotten this far building our card game, but it actually has kind of a fatal flaw that's a little bit hard to see. And the reason it's hard to see is we've been doing.
Let's see what the fatal flaw is. It does a stack here, horizontal stack, and then padding, and then make everything the same.
Doing this whole thing with our preview window in what's called light mode. So in iOS 13, they introduced this concept of having your phone in dark mode or light mode. So in dark mode, the background is black, pixels are basically off as much as possible, and your UI is light colored in contrast to the black background. And these cards look fine. They look just like what we see over here. And you'd think, oh yeah, we did a good job. They're kind of tall and skinny, but they at least look like cards. But they don't look very good in dark mode. And it's a great opportunity for me to show you how adjust this preview, because we just accepted what this preview has chosen to show us. For example, this happens to look like an iPhone 12 mini because we ran that in the simulator, so it chose that for us. Maybe when you run it, if you don't choose iPhone 12 mini, it'd be something different. Well, I want to be able to control what kind of phone I see right here, and maybe I even want to have different kinds of them looking here at the same time as I change things. Here's how we customize this preview, and I'm not going to go into the great detail, but I'm going to give you the general concept. And just like with all of these things, you're going to learn more about it.
Could you interact with that phone?
So this
kind of
preview
like a
is
simulator
with this code that we moved out of the way.
Oh.
So this code down here that controls how your preview looks. And right now, don't worry too much about these 2 lines of code here, but you can see it's just displaying our content view. But if we click on this content view, oh, it has an inspector as well. We can, for example, choose a device. And we can also pick the color scheme here. And when I pick dark mode, it puts this into dark mode, and you can see our cards don't look so good in dark mode. And it added this line of code right here. This is a view modifier that's modifying our content view. Remember, our content view is just a struct that behaves like a view, so it can have these, whatever the view modifier, padding, etc. So this is just like padding, it's a view modifier that says, hey, when you display this thing, please prefer this color scheme dark. So now
see the answer and don't feel like coding it. I've been falling into that trap quite a few times. It's always hard to code out what you really think. There's some really edge cases sometimes, but I don't know about this question.
I see dark. But what if I want to see it in dark and light? I want 2 simulators in here. No problem. We can actually copy and paste and have the second one, instead of dark, be light. So now I have both a light and a dark little preview.
Yeah, I feel bad copy and pasting code.
Inside here, we can kind of put however many views we want. This is essentially a Lego bag of Lego view builder thing here. And we just list as many as we want, and it'll make a simulator for each one that it encounters. What's wrong with our cards here? Well, they really want to have this white background even in dark mode. Cards, it doesn't really make sense for the cards to essentially be transparent.
There's like a few.
We want this filled in white. How are we going to fill this thing in white? Well, unfortunately, rounded rectangle, there's no way to have one be stroked and have this red border and then also filled. So having dot fill here actually would mean something slightly different. When we said stroke, that actually took our rounded rectangle, kind of made a racetrack around the edge of it, and that racetrack is only 3 points wide, but it could be even wider. And so when we say dot fill right after a dot stroke, we're actually talking about filling the racetrack that we made around the edge. And in Swift, you can fill with other things besides colors. You can fill gradients and patterns and things like that. So you can see how fill could be useful for filling what's actually in that racetrack. But here what we want is to fill the inside part, the part inside the stroke, not the racetrack itself, but what's inside the racetrack, the middle of the rounded rectangle. We can't do that with a single rectangle. There's just no way to both create the racetrack around it and fill the middle of it. So we're going to need 2 rounded rectangles actually. So I'm going to copy and paste this, and I'm going to create 1 rounded rectangle that's filled, and then on this Z-stack, remember, Z-stack stacks them on top of each other. So I've got a filled rounded rectangle, and then I put the stroked one on top of it. Of course, I want the filled round rectangle not to be filled with red. I want it to be filled with white. So I'm going to say down here, dot foreground color dot white. And it's going to fill our rounded rectangle with white in the background there, and then put the red on top of it. And it looks good in both dark mode and light mode. That was a little bit of an excursion, mostly to talk about preview, kind of a good example of showing why I would want to go down to my previews and create other previews. And we'll learn as Corey goes by that there are other view modifiers that you can do that make them appear differently when they're being previewed. All right, so that's enough of that. We've got our nice cards here. We've got multiple cards, that's good. What about face up and face down? All of our cards here are face up, but in our UI over here, these cards are face down. And if I touch them, oh, they go face up. So face up, face down. How do I make my card appear face down? And then how do I make it so when I tap on it, it'll switch between face up and face down?
There's some
What is this
finger
for?
actions
Simple.
from
Let's go
UI.
ahead and talk about face down. Here's our code that looks face up. I don't know if you remember when I first talked about these Lego bags, right? The bags of Lego things that would
If
have them
statement
as a
in
contact
there.
argument here to the ZStack view combiner. But I said it could have ifs. I can put an if in here that says if is face up, which I just made that up, by the way. This is face up. We'll have to do something to make that exist. Then I'm going to do this. But if it's not face up, then I'm going to just have a filled rounded rectangle, because that's what our face down cards look like. This face up is, I just pulled it out of my hat, so it's not really something. That's why it says it cannot find is face up in scope. But all I need to do to have something like is face up that controls how I look
There's some
is just
UI
add another
action.
variable. So I'm going to say var is face up is of type bool. So it is a Boolean. And that's going to get rid of this error because I've got this Boolean and I'm just checking this Boolean in my struct. Couldn't be simpler. Uh-oh, though, got some errors up here. Why did fixing this is face up thing here cause errors up here?
Why does you call a function? It doesn't have a default value, right?
Here where I'm creating my card views. Well, this is actually happening because of a very important rule in Swift, the Swift language. So let this sink in, this rule. You cannot have variables that have no value. Variables
Hey, we got
always
it.
must have a value. From the time they're created all the way for their entire lifetime, they must have a value. There's no such thing as a variable with no value in Swift. Now, there is a kind of variable called an optional, which we'll talk about next week, that looks like it's no value, but it's not that it's no value. It just has the value not set yet. It's a little bit different, but a Boolean has to either be true or false at all times. This up here, I'm going to explain why this error is happening up here in a moment, but let's talk about how this thing can get a value. This is just a variable, so we could do the same thing we do here. Let's just put a little function here and have it return false. Is face up. The value of this variable is now going to be calculated by executing this function. This function returns false, so when we go back here and try again to build, and by the way, when you make a change that won't compile, sometimes your preview will say, I can't do this. It doesn't work. And so when you try again, it doesn't always work the first time. Sometimes it takes a couple of try agains. But it does work. Look at that. All of our cards are face down. Is face up, returns false. They're all face down. And if I change this to be true, then all of our cards are face up. So that's one way to do it. But we would probably not use a function here when we can do something much simpler, which is equals true. When we say equals true, we are giving this variable an initial value. And it's currently with the way our code is, it keeps that value forever. So these cards are always face up, or I can say false and now resume, and they're all going to be face down. So that's one way to do it. But what if I don't provide a value here? I don't do the little function way and I don't do equal something, then what happens? Then I get these errors up here. And what this is saying is missing argument for parameter is face up in call to create this. If you have a variable in one of your views and it's not given any initial value, then you have to provide that value when you create the view. And we do that by saying is face
Attack.
up, true, for example. Notice that eliminated that error for this line. It's completely gone because we are now initializing this variable. This hopefully to you looks very similar to this, right? When I was creating a rounded rectangle, I had to provide this argument corner radius. This is not the only way to make this work, so I'm not sure if corner radius really is a var inside the rounded rectangle view. Might be though, but if it were, this is exactly the same kind of syntax that you're gonna get as we get up here. So we can do this for all our cards, give them all a face up, and we can maybe have them be different. Let's have maybe these two middle ones be face down, and the two side ones be face up. We resume, and it, sure enough, it's working perfectly.
Jasper, we finished the streak today. Trying to study the course.
It's an important thing to understand about these variables. They have to have values, and if you don't
Go
set
back
them
to binary search
inside
tomorrow,
your view,
though.
then whoever creates them is going to be forced to do it. Oh, by the way, if you define this to be, for example, true, then this is going to override that. The person who's creating it wins if you've got both a default value and you specify a value here. So notice that these two guys who say that it's false, they're still winning. Those are face down, even though the default is true. But it does allow us to remove this. You can remove this, perfectly legal now because there's a default value. And if we remove it from these two, then we're going to have them all be face up. Okay, so before we move on with our card here, I want to take a little time out here to show you something else we can do with a bag of Legos view down here. When we added this is face up var, kind of copied and pasted a little bit of code right here to make the back of the card, right? We had this, we copied and pasted it, and I'm just starting to notice that that copying and pasting is resulting in my having this same little expression multiple times in here. And of course, in programming, we don't want to do that. We want to be able to use local variables, for example, to store things like that. So a bag of Legos view, in addition to having a list of views, obviously, and these if-thens, can also have local variables. I'm going to create a local variable here. I'm going to call it shape, which is going to be the shape of my card right here, shape. equals, and I'm just going to put my little rounded rectangle here. And now that I have this local variable, I can replace all the times that I use this with shape. Shape here, shape here, shape here. And since this has made this such a small little word in my line of code, I probably would even put these on the same line right here. I could do the same thing with my text. So I've got a double benefit here of not repeating typing this over and over and making my code a little tighter, a little easier to read, a little easier to understand that there are three things that are Z stacked together here to make that work.
It's
You notice that
constant.
doing this introduced this little warning here, this yellow warning. And so we always want to fix our warnings. You know, the red errors we have to fix, but the yellow warnings, really we have to fix those too. Our program might function, but if warning sometimes is an indication something not going so right. Let's take a look at this one. It says variable shape, that's this thing I just introduced, was never mutated. It says consider changing it to a let constant. So it's saying call this let instead of var. So I'm going to do that. Instead of var, I'm going to type let, and that means let this shape equal that, and no more warning. So what is the difference between var and let? Well, var is short for variable. That means something that's going to vary, something that's going to change. And clearly our rounded rectangle is going to always be our rounded rectangle here. It's not going to change. So that makes this really a constant. So we always want to use let when we're defining variables that are not really variable, they're constant, and use var when they're variables. Now this is a var because it's changing every time someone asks for it because it's executing this function to find the value. So lets are just constants that we set things to. Now, one thing that's interesting about this line of code here, kind of different from this variable up here, is that there's no type. Right up here we have the type Boolean. Here we have a type also, some view. There's no type in here. And of course the type
You've
of this is
constructed though.
rounded rectangle. And we didn't have to type this. Swift, again, doesn't like us to have to type the same thing over and over. So it says, no problem, I will figure this out for you. If you just leave this off, I will figure it out for you. And that's, again, not only good for less typing, but if we decided, we left that in there, we decided, no, I want my cards actually to be circles. I'm going to type a different kind of shape in here, a circle. Well, of course, that's going to generate an error because a circle is not of type rounded rectangle. But if I had left that off, then when I changed this to a circle, it would all just work. See, look, the things changed to be circles instead of rounded rectangles, and this shape automatically changed to be the right type. We let Swift infer the type. You're going to hear me use the word infer when I'm talking about types a lot in this course. And inferring a type just means the Swift is going to look at the context that this thing is in, and if it can, and most of the time it can, it'll put the type in there for you. So we do not put these explicit types in
Compiler
here
doing its
when
job.
Swift is able to infer them. Let's go back to rounded rectangle. The next thing I want to do is have it so that we can see our face up in real time in live action with the user by making it so that when we tap on one of these cards, it flips it over. Just like we have in our app over here, every time we click on it, again, it's not going to be animated like we have over here because we're just getting started, but at least we'll be able to see the face down and the face up versions of our card really easily. How are we going to do that? Very simple.
How are we gonna do that? Let's guess. Let's take a look first. This one calls a CardView. I put a or like a check state here. I think I'll put a variable here and flip it. Constantly running loop.
I told you that something that behaves like a view, like our card view does, or even like our content view does up there, it not only knows how to draw in its rectangle, but it knows how to receive multi-touch events and react to them. And we're actually going to spend pretty much an entire week talking about doing that. But the simplest way is a tap gesture. You can do that with a view modifier. So I'm going to add a view modifier to this Z stack. My Z stack represents an entire card. It's called on tap gesture. And it takes one argument, which is got the perform label here, and the argument is a function. Now this, again, surely you're not surprised to see functions as arguments at this point, but this function, it's not a view builder or anything. We're not making a list of views or a Lego bag here. Here we're just talking about just a regular function where we can do anything we want. And in fact, this function does not even return anything. It just lets you do any code that you want in here. And since this is the last argument and to this function, it's the only argument to it, we can remove this little keyword and remove the parentheses so this looks really nice and clean as well. What do we want to do when we tap on a card? Well, we want whatever face upness it has, face uppedness, to flip over, to be the opposite. So we essentially want to say is face up equals not is face up. We just want it to flip over. But unfortunately, you can see I'm
But you
getting
need to
errors here.
call it
Cannot
again
assign a
though.
property. Self is immutable. It's basically saying I can't set this variable right here because self means my entire view, that's the code I'm in here, is immutable. And in fact, that is the case. All views in SwiftUI, every single one you see here, every one you're ever going to see, is immutable. cannot be modified. And you might say, well, how does my UI ever change then? Well, when things happen, for example, in your game logic or whatever, your entire UI is being constantly rebuilt. New views are being created to reflect the changes in your game logic and replacing old views. And of course, that's happening very efficiently. That's one of the great things about SwiftUI is it
You have
allows
to
for
call
this
this
entire rebuilding of your
again.
UI highly efficiently, but all the views are being replaced. There is no way to actually change this var, even though we call it a var. Once it's initialized either by the creator up here or by using this default value, it cannot be changed. All right, and that takes a little bit of getting your head around to understand that when our UI is changing, it's because all these views are being rebuilt, but that is the case. Now, we are not going to be working on the logic for our app until next week, and it is the logic that drives what the views are supposed to look like. But there is a small way that you can kind of create your own, you can think of it as like mini logic, but it's really just create a tiny little outside of the view storage space and have the view just look at that. And when that changes, the view will get rebuilt, but still pointing to that little piece of memory. And you do that by changing one of your vars to be @state. So putting @state in front of a var, a lot of people when they first are learning SwiftUI, they think, oh, that makes this writable somehow, that now this view is mutable, it's got this variable is writable. But that's not true. This view is still immutable. It just turns this variable, instead of really being a Boolean, it's actually a pointer to some Boolean somewhere else, somewhere in memory, and that's where the value can change. But this pointer does not change. It's always pointing to that same little space over there. Now that might seem like a fine distinction, and it is somewhat of a fine distinction, but it's not really too much to worry about because we really don't use @state very much. It's pretty good at the beginning of the quarter when we don't have our game logic to drive our UI and we just want to do something like change our isFace up around. But when we actually start building apps, we're not going to use @state very much. It's mostly just for temporary state. Things are like I'm in the middle of a drag or a pinch multi-touch and I want to keep some state as the drag is going on. And when the drag's over, then I don't care about the state anymore because my logic will have changed presumably. Or you can use it just for state that only affects the way your view is displayed, not the logic of how your UI is playing a game or whatever. So we'll use this little @state. Notice that the arrow went away. Now we are able to do this isFace up. If I click on cards, okay, we failed here, of course, because we introduced an error. So let's rebuild.
Wait, isn't that a pointer? You
All right, there we
just
go. So
flip
now
the
if I click on card
pointer,
here, hopefully it should flip
note the
over, right? And
reference,
click. Oh, wait a second. My preview here, when I click, it selects things, right? So, how am I going to check to see if my tap gesture works?
change
Well, one way is
here,
I
I
can run my
guess.
simulator. So I'm going to go launch my iPhone 12 mini simulator here. Here are my cards, and I tap. Woohoo! It's flipping them over. Nice. IsFace up, up and down. Very nice. So that's working. And this works here. We can rotate. Works over here. Very nice. Okay, so that's good. It's a little bit of a bummer, though, that anytime I want to test some multi-touch gestures, I have to go all the way back out to my simulator. I've been so used to doing it here in preview. Well, of course, we can do it in preview. All we need to do is use this little button right here. You see where it says Live Preview? If I click Live Preview, then it goes out of the mode where clicking on things selects things, and it still have pause and resume, so I'm going to resume here, and it's going to be showing me the latest UI, but now tapping in here is not going to select. It's going to do any multi-touch gestures like this one. Ready? Ooh. You can switch back and forth really easily. Turn off live preview. You're back into clicking on things to select them, then back into live preview to make sure that your multi-touch gestures are working. So just to summarize here, when we are changing face up as a result of this tap gesture on the Z stack, we are actually changing it in memory somewhere, and our isFace up is pointing to that. So whenever it changes, SwiftUI is smart enough to notice, oh, whoops, this thing is pointing at some isFace up Boolean somewhere that changed. I need to rebuild this view, and it will recreate the body right here. And when it recreates the body, of course, the isFace up will be different, and it'll choose whichever of these makes sense, right? Whichever of these if cases make sense. So that is the process by which this is happening.
Well, it
And this
saves
is
a
a
lot
little
of work
miniature of the way
too.
SwiftUI works once we really have our game logic going. When the game logic changes, it notices which views are going to change.
Like realistically, like after you, well, this is not dereferencing to be honest. And like after you change this variable, it needs to be the right function to detect the change of this, and then we'll call CardView again. Actually save quite a lot of work.
As a result, and it rebuilds their body. That's why it's rebuilding this all the time. These things are read-only, so if something changes, we have to rebuild its body. So what else can we do here? Well, all of our cards, unfortunately, are airplane cards. It'd be really nice if we had our cards be something like this, where they were different vehicles than airplanes. So let's do that. How about, where is our airplane? Okay, airplane is right here. So this little string is in every
Another
single card view we
pointer.
ever create. That's why they're all airplanes. But what if we parameterize this? Just like we have this isFace up var here, what if we create another var? We'll call it content because it's the content of our cards. It's just going to be a string. A string, by the way, very important struct inside of Swift. It is, obviously used in text and everything else. This is the kind of struct that you're going to want to become familiar with by looking in the documentation. And in fact, let's take a little brief look at how we can look in the documentation, because there's a quick way to get into the documentation from your code, which is to use Option key. Holding down Option, you see it turn to a question mark there, and click. When you option click, it's going to give you a little
I don't have
summary
an
from the
option key
documentation
though. I
about
have a
this type you
VM.
clicked on, in this case, string. See, tell you just kind of a little bit about how it works. But you can also click open in developer documentation. It'll bring up the documentation. Now you get a long description of everything that string can do. I told you it was an important struct. You can do a lot of things, and a list of every single function and var that it has and what they do, what the arguments are, how to call it, etc. Lots and lots and lots and lots of stuff in here. You can also search if you go up to search documentation up here, search for other things. And I try to make it so that you are going through this stuff as you learn this stuff. Asking you to go through the entire documentation and learn stuff would be a challenge, to say the least. It's very SwiftUI, obviously very expansive, but this is something you don't want to skimp on either. And when you get to important classes like string, and we're going to talk about array in a moment here, those are things where it's really good to read this introductory section right here. And past that, you're going to be searching through here a lot to find functions and variables that you're looking for. But eventually, you will become a master of all of this stuff in the documentation. You can also bring up the documentation, by the way, up here in the Xcode menus window. Developer documentation brings that same window up. All right, so if we have this content string, then we could just use this content right here. Content, and that would choose that content, whatever this var is, instead of the airplane. Now, just with face up, like with face up, this has to have a value. This can't be just set to nothing. There's really no good default value here. We don't really want our cards to default to being airplanes. Well, this is the same errors we were seeing before with is face up. And we're going to fix it in exactly the same way by saying, all right, you've got this unset variable content. I'm going to set it for you. So let's set it and pick some vehicles here. Edit, emoji
I want to
symbols.
randomize that eventually.
This is cool. Do a little bit of copy and paste to make this go quicker. All right, so we have now changed this content argument for each of our card views. And so when we resume, our cards look different. All 4 cards are different. And we're still in live preview, even though we resumed and we changed code, so we can still click. So that's really neat. We got different cards going on right here, but it's a little bit, we wouldn't really probably never write our code like this where these 4 emoji are kind of hardwired in here. We really would rather put these in an array or something like that, and then pick these out of an array. And eventually we'd like to have a for loop in here. But I think I mentioned earlier that these bags of Lego, while they can have local variables and ifs, they cannot have a for statement. So we're going to need a special bag of Lego making view that does for loops. So we'll see that in just a second. But before that, let's just put these 4 things in an array, because we need to learn about array anyway. Array is a very important struct, just like string in SwiftUI. So I'm going to put this up here. Var, I'm going to call it my emojis. And I want it to be equal to an array of things. And in Swift, you can just put open square bracket, close square bracket, and a bunch of things listed in there, and you just created an array of something. So I want to put these 4 emoji in there. It's as simple as that. Now, once again, notice I didn't specify the type down here. I let Swift figure it out for me automatically. But if we wanted to type this here, what type is it? It is an array. But just like in Java, you can't have an array that's just an array of string typed things. Swift is very strongly typed, and it wants to know what type. So in angle brackets, you put what type is in the array. So this would be the type of our emojis var here. It's an array of string. Now, arrays are so common to create in Swift that there's a little bit of a shorthand for doing this, which is square bracket string. That's just another way of saying array of string. Exactly identical, not a different type. It's exactly the same as array with angle bracket string. But again, we don't need that. We'll just take that off. We'll let Swift infer it from what it sees here, which is that it's an array with strings inside. Now that we have this array right here, we could replace these here with emojis sub 0, for example, and then emojis 1. So arrays are indexed from 0th element, like most languages do. And we have to be very careful here. We wouldn't
feels
kind
of like C++, a little bit.
The bounds of it, because if you access an array outside of its bounds, if you use an index here that's outside of its bounds, you will crash your app. Your app will raise an exception and crash. And kind of you want that, because if you were outside of the bounds here, that's probably not good. You'd want to find that in your development process before you ship it out to your customers, right? So that's pretty cool. Get our emojis there. Let's make sure that still works. Resume. There it is. Works nicely. By the way, that option click that we did down here on a type, if you option click on a variable, like emojis, it will tell you the type. In this case, it says that it's an array of string. And of course, you can click here and go directly to the documentation as well. We're getting closer and closer to making this kind of a more extensible, expandable kind of UI for our cards. The next thing that I want to do here is do that for loop like thing that I was talking about in here. We can't use a for loop, but we'll talk about what a for loop looks like in Swift later. But first, we're just going to do this new bag of Lego thing that essentially is a bag of Lego that creates a view for everything in an array. And exactly what we want here. We want to create a card view for each of the things in our array. This bag of Lego view that does that is called a for each. And it just takes the array that you want to create something for each, and then it has a content parameter, which is another bag of Lego. So it's going to essentially create this bag of Lego this many times, however many things are in here, and then this itself will become a bag of Lego. So since this is going to be a bag of Lego, lots of Lego here, it only makes sense to put a for each inside something like an H stack, a view combiner, because the for each itself is not a view combiner, it's just a bag of Lego maker, right? It makes a bag of Lego filled with stuff by doing something for each of the things in this array. This content can just be our card view. So for each of the emojis in here, we're going to build a card view. So now we don't need these. And of course, we're not going to build the card view with the first thing in the array. We really want to build it for each emoji somehow. Somehow we're going to have to specify the emoji each time this goes through. And to do that, we're going to show you something new, which is that functions like this is a special view builder function, but still function, can have arguments. None of the functions we've seen so far that we've used here has had any arguments. Some of them have returned things, obviously, but none of them have had arguments. So how do you put an argument to a function? Well, you just put the name of the argument and in. And there can be multiple arguments, of course, arg2, arg3. You can have as many arguments as you want. In this case, the for each only wants to pass one argument, which is the thing that it's currently working on as it goes through each of these. So this is going to be the emoji string. So it's going to be the train the first time through, and we're going to create a card view of a train. Then there's going to be a rocket ship the next
Content
time through. We're
view.
going to create a card view for the rocket, and those are all going to be put in this Lego bag that's being created by this for each. Very simple. Now, we still have an error here. It says a referencing initializer for each requires that string, which is the things in the array right there, conform to identifiable. You're going to see this phrase conform to quite a bit in this class, and it's really the same as what I was saying when I said behaves like. So this content view behaves like a view. This card view behaves like a view. These things in this array, if you want to do a for each, they must behave like an identifiable. See this thing identifiable? What is an identifiable? It's a thing that has any kind of struct can be an identifiable, but it has to have a var called ID, which uniquely identifies it. Now, why does the for each want the things in this array to be uniquely identifiable? Because it's going to create a view for each of them. And if, for example, this array right here should be reordered, or new things added to it, or things removed from it, etc., it needs to know which things changed in the array and then adjust the views accordingly. So it needs to be able to uniquely identify everything in the array to match up the view that it's going to create for them. So it makes total sense. Of course, the things that we're doing for each, we have to be able to uniquely identify them. Now, unfortunately, a string has no such thing. If I had two trains here, there's no way to tell this train from this. They look exactly the same. Now, this is not going to be a problem when we build our real card game over here, because our for each is not going to be going for each through emojis. It's going to be going for each through cards. Our game obviously knows about some concept of a card, and we have to go through the cards because some cards can be the same. This checkered flag and this one, same emoji, but those are clearly different cards. Look, the timer is different on this one right here, and obviously I have to see if you've chosen these two cards and see if they match, so they have to be different. So it's not going to be a problem when we have the logic of our game. But in our little demo here where we're just making strings, it's a problem because there's no way to uniquely identify these strings. So we're going to work around that in our demo world here, just by picking a different string for every single card. All these cards, look at that, different vehicle. There's no two vehicles alike. And we're just going to have to live with that. And if we do that, then we can go back here to for each and tell the for each, yeah, just use the string itself as the unique identifier, even though it's not actually unique. Do it anyway. We do that with another argument to for each in addition to the emojis and the content here called ID, which tells it how to identify it. And it's kind of weird syntax here, which is we do \dot, and then we can put the name of a var here that string responds to. And that's what it's going to use as the identifier. The string doesn't really have a var that's unique, as we know. So we're going to use a special var called self. Right? All structures have this var on themselves called self, which means the struct itself. So that's perfect for string. If I say dot self on a string, I get the string itself. So now this string is in fact the identifier that the emoji is going to use to identify them. Now let's see what happens when we do that. We'll run it in our simulator first because we want to be able to flip these over here. Here we go. We got our 5 cards. See, 2 trains and the other 3 things. That's what we have here. 2 trains and the other 3 emojis. And if I click them over, they're working great, working good. Yeah, the train. Uh-oh. You see when I tap on the train, it's using the same view for both of these because, again, the for each can't tell these apart. So when it sees the train, it uses the card view it's already made for a train over there. And that's kind of weird behavior, and you really would just never want to do this, okay? You don't really want to have arrays that have non-identifiable things in them be passed to for each. So we're not going to do that. We're going to go back to having just the 4. We're still in preview mode over here, so this is working fine over here as well. We can clean up our code a little bit here because, of course, content is a function, an argument that's a function, and it's the last one. So we can take that off of there, get rid of the parentheses. Now, the next thing we're going to do is put these little buttons on here. Add cards, remove cards. We want to be able to add and remove cards. And to add and remove cards, we can't have this fixed array that is always being entirely displayed right here. We want to be able to vary the number of things that we're showing. So I'm actually going to do that by creating a much larger array, and then here only showing a subsection of the array, depending on how many of these cards we want to show. And just to make this typing go fast, I actually have a little code snippet that does 24 vehicles. But I'm only going to show the first, let's say, 6 of them. So how do I have an array, a big array like this, and then only show some of them? Well, we can index into the array, and instead of doing a single index like 5, which would just be one of them, I can actually do what's called a range. This syntax right here is a range. There's both this kind of range, which is 0 up to, but not including 6, or up to and including the number 6, which would be 7 items over. So here we're saying just pick the first 6 of these. So let's see if that works. Sure enough, we got 6. We'll flip them over, looking good. Be able to do the same thing right here. Resume. Get 6. Excellent. Now, if we change this 6 to 4, now we're only getting 4. If we change it to 8, now we're getting 8. Our plus minus is essentially changing this number right here. And when we go over here and say more cards, please, or fewer cards, please, we are changing that number, that 4. So this just wants to be a variable. So let's make a variable for that. I'll call it my emoji count, and it's going to be an int. And we'll start it off at 6, let's say. Of course, we can have Swift infer that int, so we don't need that, because this is clearly an integer right here. If we said 6.0, by the way, it would infer it to be a double precision floating point number. So let's take this emoji count and make that be the max emoji count. And let's resume over here. We got 6. If we change this emoji count to 3, we'll go down to 3 cards. If we change it to 10, then we have 10 cards. So this is great. All the buttons we are going to.
Cool. Okay. I need to get a bio break. Near the end anyway. Let's just resume again on Thursday, probably even earlier than that. Surprise streams. Finish this up. And I think next time we come to this course material, we can get to the assignments. More interesting. Cool. Thanks for watching. And care. See you guys tomorrow.